Hey guys! Today we're diving into the hidden history of the internet that you won't find in textbooks. So let's jump straight over to my screen.
Welcome to this explainer. So today we're diving into the absolute wild ride of how the internet was actually built. We literally use it every single day, right? I mean, you're using it right this exact second to watch this explainer. But the real story of how it came to be, it's probably not what you'd expect. It wasn't just some lone genius having a eureka moment in a garage. No, as we're going to see, it was actually a series of incredibly ingenious, kind of desperate solutions to some of the biggest, scariest global challenges of the 20th century. Which brings up a question we hear all the time. Who actually invented the internet? We love the idea of a single brilliant mind, suddenly cracking the code. But the reality is way more complex, a massive group effort, and honestly, a whole lot more interesting. Because get this, it didn't start with anyone wanting to share photos or stream movies. It actually started with a massive existential threat to national security.
All right, let's get into it. The story really kicks off right at the peak of the Cold War in the late 1950s. The US and the Soviet Union were locked in this fierce, high-stakes technological race. And then the Soviets did something that just sent shockwaves around the globe. They launched Sputnik, the world's first artificial satellite, right up into space. It completely blindsided the American scientific community. Suddenly, the threat of a nuclear attack felt incredibly real, and the US government realized, oh wow, we have a massive vulnerability on our hands.
So, in response to that Sputnik panic, the US government formed ARPA, the Advanced Research Projects Agency. Their absolute top priority? Build a communication system that could actually survive a nuclear strike. See, back then, telephone networks were entirely centralized, super vulnerable. If an enemy took out just one central switching office, boom, the whole country's communications grid goes down. But then, a visionary scientist named J.C.R. Licklider steps up. He pitched this radical, almost sci-fi alternative, a decentralized galactic network, a system where computers everywhere could talk and share data instantly, making the whole network virtually indestructible.
To actually pull this resilient network off, researchers came up with a total game changer called packet switching. Instead of sending a message as one huge clunky file down a single vulnerable wire, they chopped the data up into tiny little pieces, packets. Think of it like writing a letter, cutting it into individual words, mailing them all in separate envelopes, and then they just magically reassemble perfectly at your friend's house. Each packet traveled independently, taking totally different routes. The sheer genius of this was that if one path got wiped out by an attack, the packets would just simply route themselves another way. No big deal.
Section 1. The first message crashes. October 29, 1969.
So we had the theory, we had packet switching, and now it was time for a real-world test on a brand new system called ARPANET. A student named Charlie Klein was sitting at a computer terminal at UCLA, getting ready to make the very first connection to a computer miles away at Stanford. His goal was super simple, just type the word login. So he sits down, types the first letter, L. He's on the phone with the Stanford team, and they eagerly confirm, yes, we got the L. The first letter actually made it through. Feeling pretty good about it, Charlie hits the next letter, O. Stanford checks their screen, and they confirm they got the O. The system was actually working. They were literally making history right there.
And then the entire system just completely crashed. Yep, that was it. The very first internet message in the history of humanity wasn't some profound quote for the ages. It was just a very anticlimactic LO. But hey, despite the crash, the fact remained. The data had traveled, the fundamental groundwork for the entire internet had successfully been laid.
Moving on to Section 2, the Universal Machine Language, in the 1970s.
As we rolled into the next decade, that initial success brought up a massive new headache, the language barrier. As more universities and labs scrambled to connect to ARPANET, they hit a huge roadblock. They realized all these different computer networks were speaking entirely different digital languages. A computer on a network in, say, California literally couldn't understand a computer on a network in Massachusetts. The whole global system was completely fragmented. It was basically like trying to host a massive international summit, but nobody bothered to bring a translator.
Enter two brilliant engineers, Vint Cerf and Bob Kahn, guys who are often called the fathers of the internet today. They stepped up to solve this massive crisis by designing a universal language so any network could finally talk to any other network. They invented the Transmission Control Protocol and Internet Protocol, which you probably know today simply as TCP/IP. It was the ultimate digital translator.
So how do these two actually work together?
Well, think of TCP/IP like a flawless global postal service for your data. TCP is the packaging department. It makes sure your message is broken down correctly into those little packets we talked about, and then reassembled perfectly at the end without any errors. IP, on the other hand, acts as the mailing address on the envelope. It makes sure that data navigates this huge network and lands at the exact right destination computer.
And that brings us to a huge, huge date. On January 1, 1983, ARPANET officially adopted this TCP/IP protocol across the board. This was a massive milestone because it allowed all these completely separate, isolated networks to finally merge into one single interconnected web. In fact, January 1, 1983 is pretty universally considered the official birth date of the actual internet as we know it.
Which brings us to Section 3, the Web for Everyone, 1989.
Now, you might think, okay, story over, but we still had one giant leap left. See, the internet of the 1980s was this exclusive, super text-heavy tool. You had to have deep coding knowledge just to use it. But over at CERN, the big physics lab in Switzerland, a British scientist named Tim Berners-Lee was getting pretty frustrated. He noticed how ridiculously difficult it was for scientists to just share basic information stored on different computers. It was tedious, so he decided to just blow the doors off the whole thing. He built a user-friendly visual layer to sit right on top of the internet infrastructure, and he called it the World Wide Web.
To make this a reality, he invented 3 critical building blocks. And by the way, you are using all 3 of these at this exact second to watch this explainer. First, HTML, the coding language used to actually write web pages. Second, URL, the unique address to find the page. And third, HTTP, the protocol to retrieve it. And crucially, alongside those 3, he threw in the absolute magic of hyperlinks, that clickable text that lets you instantly jump from one page to another.
But honestly, here is maybe the most astounding part of the whole story. In an act of just incredible, world-changing generosity, Tim Berners-Lee chose not to patent his invention. Seriously, he didn't lock it down. He didn't try to become a billionaire off it. He gave the World Wide Web to the global public for absolutely free.
And giving it away like that, it sparked an absolute explosion of global creativity. Think about it, from the total panic of Sputnik in '57 to that first crashed LOPH message in '69, the birth of the internet in '83, and then the web in '89. Because the web was free, it led straight to the 1993 release of Mosaic, the very first graphical web browser. Suddenly, ordinary people could see pictures and click links on a screen. The internet transformed practically overnight from a cold, text-based military experiment into this vibrant, colorful public square, paving the way for the entire digital universe we live in today.